All right, so today I'm very excited to present you ZetaChain, the first universal blockchain for all crypto. But first, let me just give a short introduction about myself. So I'm Lucas. I joined ZetaChain last year, and I'm helping developing the protocol, ZetaChain, the blockchain itself. Before that, I've been contributing to multiple crypto projects. I've been working at Tendermint, for example, and also some project in Ethereum. I started in crypto in 2017. And while I think people in this room may have started earlier than me in crypto, I still started in crypto early enough to see a lot of changes in the space. Like, for example, in 2017, you were building on Ethereum mainly, so the only chain you could deploy smart contract was mainly Ethereum. The chain was so cheap that you could even do your testing on Ethereum mainnet. And throughout the time, we've seen a lot of different narratives. So in 2017, the idea was Ethereum has a world computer. Then we had the ICO bubbles, the DeFi summer, NFT bubbles, a lot of Rook bubbles as well. So we've seen a lot of changes. There are more stability than before. But we know at least two things. First, crypto is a thing. So there isn't anyone that said that crypto gonna disappear in the future. And the second thing is that we're going multi-chain. So despite the conference being L2con, there is still interest in building your L1. Like one example is for sovereignty, but many other different advantages. On the L2 side as well, so we have a lot of innovations happening in rollups, projects developing their own standards, their own solutions. So you have OP Stack, Cyberchain, for example, but you also have Elastic Chain with ZK-Sync. So you have many different standards happening for building L2 ecosystems. And it's very, very unlikely that we're going to be in a scenario where winner take all. So crypto is multi-chain. We know there are many different solutions to create your own blockchain, and there will be a lot of new blockchains appearing in the future. And this brings a lot of issues for developers and for users. So if you take users, for example, if you want to take full advantage of DeFi, there are many different wallets you need to interact with. If you want to interact with several blockchains at the same time, it's a lot of different interactions with different technology, different standards. So it's very complicated user experience. For a developer as well, it's very complicated. You need, if you want to take full advantage of the ecosystem, you need to deploy your smart contracts on different chains, different technology, eventually learn different languages. And so for this situation, multi-chain, we have solution for this, new bridges, different solutions, but there's also issues with many solutions that we have right now for building cross-chain applications. So there are a lot of fragmentations. If you're developing applications using bridges, for example, there are still different chains that you need to build on. It's also high risk. Many solutions use, for example, centralized multisig. If you take like the main vector of the latest exploits, it has been mainly around bridges. Most of the fonts that have been compromised through exploits. So in the space, building cross-chain decentralized applications is something that is at the same time hard to do and also very dangerous since there are many exploits happening here. So the idea is, what if we had just a single place where you can build your applications and use any blockchains that you want, and also for any users, use any blockchains without thinking about what chain you're using. This is the main things that we are focusing on. This is our mission. So to build a platform that developer can use to create decentralized applications without thinking what underlying chains they're working on, and also for users interacting with cross-chain applications without having to use different wallets, interacting with different protocol at the same time. So ZetaChain, on the very high level, what it is. So we are building a L1 that is EVM compatible and that is natively interoperable. So you can deploy smart contracts in Solidity, deploy it on ZetaChain, the same as you do on any other EVM chains. And those smart contracts can be natively interoperable. So you can deploy a smart contract on ZetaChain that can receive assets from Ethereum and then withdraw other assets on Bitcoin, for example. So we're not only connecting EVM chains particularly, but any kind of chains. So that's on a very high level the blockchain. So now, given this solution that we're building, how do we fulfill this vision of chain abstraction, allowing users and developers to build solutions without thinking which chain they use it on the background? So our main the way we take it is through what we call the universal EVM stack, which is layered architecture for representation for building cross-chain applications. So what we're gonna interface to the users and developers is what we call the chain abstraction framework, a framework to build and interact with cross-chain applications. This framework is powered by what we call the universal EVM, which is a EVM connecting to any chains in the space. This EVM is powered by ZetaChain itself, which is a proof-of-stake L1 blockchain. And then on the background, the entire protocol connects to any blockchains. So first, the chain abstraction framework. This is what is interfaced to developers and the users. This framework allows developers building and deploying a decentralized application without having to think if, so there is, I want to build this decentralized application, I need to deploy this smart contract on Ethereum, for example, the smart contract on BSC. Here, there is a single place where you deploy your entire applications, and then it's automatically interoperable. It's automatically a cross-chain decentralized application. And for the user as well, they directly interact with the chain abstraction framework, and they can interact with any chain the decentralized application is connected to. More on the architecture, so you have the chain abstraction framework that is on ZetaChain. Then on every connected chains that we support, you will have what we call a gateway, which is a single entry point that you need to interact with the decentralized application. So for example, you have cross-chain DEX built on ZetaChain. You can directly initiate a swap through this DEX by sending a transaction from Ethereum to the gateway contract, or with Bitcoin, for example, sending a message to the gateway. So for Bitcoin, it's the gateway address. You don't have smart contract on Bitcoin. But yeah, any external chains, you have a gateway you interact with, and then you can interact with the entire universal applications that is deployed on the chain. Powered by the chain abstraction framework is the universal EVM, which is EVM that is natively interoperable. So the experience for developers is the same as deploying smart contracts on EVM chains. So you will build your smart contract. There is some libraries that you're gonna use that allows to receive assets from external chain or withdraw assets from external chains. And once you deploy the smart contract on the universal EVM chains, all users from the connected chains can directly interact with your universal applications. So for example, here on GitHub, for example, we have templates that provide some sort of example applications that you can directly deploy on ZetaChain to create a cross-chain decentralized application. Once you deploy your application, it is then automatically interoperable with all the chains we're connected to. So right now on mainnet, we're connected to Ethereum, Bitcoin, and BSC chain. But in progress, we are integrating Base, Polygon, and Solana, and also integrating IBC as a solution for transporting data, so to connect to the entire IBC ecosystem. So you can interact with the chain abstraction layer for any Cosmos chain through IBC. So yeah, the idea is that we don't only connect to chains, but we also connect to ecosystem, entire ecosystem. In this example, we connect to the IBC network, but in the future, for example, there's something in research phase, integrating the OP stack messaging protocol that is still in development, but so that would allow us to automatically connect the entire OP stack ecosystem to the chain abstraction framework. Where we differentiate in some way from other bridges and interoperability protocol is that we are in a structure that is more like hub and spoke. So ZetaChain is like a central hub that connects to all applications and that will receive all messages from external applications. This allows to simplify the user experience and the developer experience in the sense that if you want to interact with a universal app, you just need to directly interact with a single entry point that is connected to ZetaChain. And in particular, this allows to simplify the onboarding, the user experience for Bitcoin. So with this model, with Bitcoin in particular, if you want to interact with ZetaChain, you just need to make a transfer with a MIMO to what is called the gateway address, so the gateway to ZetaChain. And then you can call smart contracts on the universal EVM. So example, you can build a decentralized exchange on the universal EVM. On Bitcoin, you can just directly interact with the Bitcoin chain and call the smart contract on the decentralized exchange token and receive other token on Bitcoin. So this simplifies a lot the developer experience in the sense you don't need to use, for example, a wrapped version of the Bitcoin token. The user can just use directly their wallets they are using on Bitcoin to interact with the universal apps. Right now at Bitcoin, we support Bitcoin itself, but also in research phase, integrating ordinals and runes. So you can create universal application reusing ordinals as NFT directly. Oh. Yeah, that's on what is offered to the developers and the users on the high level. On the protocol itself, something also that is an advantage for us is that it's in its nature decentralized in the sense that we're building L1 that is secured by proof of stake in our case. So ZetaChain is built using Cosmos technology. It's a blockchain built with the Cosmos SDK and the Comet BFT for the consensus, which is in the space battle tested. You have many chains, like you take BSC, for example, already powered by this consensus. The chain itself is secured through proof of stake, but also the way we communicate with the external chain is secure with this proof of stake blockchain. So in our architecture, the way we observe and sign transactions to and from external chains is through a system of observer and TSS signer. TSS, three-sort signature scheme. In some way, it can be seen like a multisig in the sense that a set of actors will together aggregate to create a single transaction that will allow to communicate with external chains. Here, unlike many other solutions, the TSS, the observer signer set, is integrated in the proof of stake network. So the actors who are supporting the messaging, they are integrated as a validator on the chain, so they have high stake in the network. If they cheat, if they try to collude to cheat on the cross-chain transactions, they can be punished directly on the network. So in its nature, it is decentralized entirely. And this is the current architecture for the messaging. But also right now we're building ZetaChain 2.0, where we're doing new restructuring in the architecture. And one particular one is to separate the different layers, so the application layers that we could call the chain abstraction framework itself, and the transport layer, the technology we use to observe and sign transaction to and from external chains. So right now, TSS observer signer integrated in Zeta clients is the way we use to connect to external blockchains. But right now in development, we are integrating IBC to connect to the entire IBC ecosystem and directly use IBC to interact, being able to validate transaction from external chain and write transaction to external chains. But we also make the architecture in some way where other messaging protocol could be used to validate and write transaction to external chains. So one I mentioned quickly before is like reusing the OP stack messaging protocol being developed and use it as a way to directly validate automatically transaction from any L2s deployed in the OP stack on the superchain ecosystem, so we can connect to the entire ecosystem directly. There is OP stack, also Elasticchain. So it's a new architecture that we're building. So you have the chain abstraction framework to build universal apps, cross-chain application, natively interoperable, and then different solutions that can be used to transport data to external chains. And so if you're building, for example, a solution, interoperability, decentralized messaging protocol, right to ZK, or solutions that are similar, we can talk. We're very interested to consider integrating it to our protocol and connect the protocol with the chain abstraction framework. So as a summary, the way we differentiate from other solution, interoperability solution, is that we bring a user experience and developer experience that is optimal. So you only need to interact with a single framework without having to think what chains under the hood you interact with. So developer experience, user experience simplified, and also the protocol itself is decentralized and secure by using a proof-of-stake network. And yeah, that's it about the project. We are very interested in onboarding new developers, and so we have a grant program that we are running. And so if we are building applications that you want to be made universal, interoperable with any blockchains, you can check out our grant program. And also, we are actively hiring. So if you are engineers, also we are hiring for marketing positions, BD positions. So let us know. We're very interested. Thanks.